Yesterday, we did our first lesson just on expressions that are the same. And we went through that note. There's some homework for that. Questions from the homework? Things you wanted to go through? If not, we can jump into bed. Right? Anyone? Yeah. I'm so sorry. For me? No, thank you. Yeah. I Can somebody hand these out for me? I appreciate that. Of course, yeah. Let me get to you right now so I don't forget. So this, is online, and who knows how to go online, but this is the assignment that comes at the end. So you should go through today's lesson, and then we'll come back. There you go. Is that the only one you missed? I think so. So yesterday we talked about equivalent expressions. We're going to talk about rational expressions. You don't know what a rational is? What we mean when we say a rational expression? Kind of a weird word. In day-to-day life, what do we mean if we say something's rational? Anyone? What if someone's being irrational? It's like not very logical, right? It's kind of not thinking things. That's not what it means in math. Math, specifically, a rational is something that can be expressed as a fraction. So when we talk about rational expressions, we really just mean like functions that have fractions. That make sense? Okay. So today we're going to look at, and originally I was going to do one big lesson that was adding, subtracting, and multiplying and dividing these things. That was too much. It's too big. I kept trying to figure out how to compare it to one lesson. Because in the textbook they do it as one lesson, course outlines I found. And I decided I just wanted to split it into two. I'd just rather go slowly and just make sure you guys comfortably. And even if in today's, if we need to go a little slower to get it, that's fine. I'm happy to devote as much time to this as we need, because it is an important concept. And I promise, once you get the hang of it, you'll be off to the races. So here's a rational expression. We have an equation that could be 4x multiplied by 12x cubed. By the way, does everyone have an x on the page here? Like, does it say 12x cubed? Because my sheet, for some reason, had a missing x there, and I had to draw it in. But I thought that you do. I don't know why it's missing. There we go. So way back from grade 9, how do you multiply fractions? We would cross multiply if what were between them. Not a multiplication sign, but if there were an equal sign, right? If it was a proportion. Does that make sense? Like if I had 3 over 5 equals 2 over x, we'd cross multiply to solve that, right? Yeah, 100% good math. But in this case, it's even easier than that. It's like if I had a third times 2/5. How do I multiply that? You actually don't have to for multiplication. When would you definitely have to do that? You have to find a common denominator if you add or subtract. We're going to do that tomorrow, definitely. But for multiplication, it's even easier than that. Does anyone remember? That's right. We do numerator times numerator, denominator times denominator. And so in this example, a half times 3/5, the answer would be what? 1 times 2 is? Bueller, anyone? I'm pretty confident all of you know what 1 times 2 is. I have to like put on a musical number here? I can't say. I'll go in and fill that one in. What's 3 times 5? Okay, so what's 3 times 5? Good, yeah. So there we go. So the final fraction here would be 2/15. Does that make sense? We're working with simple numbers. Now here, we're working with variables. We're working with x's and numbers and things like that. But all the same, we're going to use the same approach. We multiply the numerator times the numerator, and we multiply the denominator times the denominator. Does that make sense? Okay, so what's 4 times 12? 48. And what's x squared times x cubed? Times x cubed. What do you do when you multiply times like that? Yep. That's okay. What do you do? Yeah, you just add the exponents. Times x cubed is going to be x to the exponent. Let's actually show it here. Show this step, but just to show it here so we all remember it. X squared times x cubed, we add those together. It's going to end up being to the exponent 5. What am I going to get on the bottom? What am I going to get on the bottom? Yeah.
6x squared.
Very good. 6x. And then if we're going to stick with this format, I guess it's a 1 plus 1. Just to add those exponents, right? But yeah, x times x is x squared. X to the 5th power over 6x squared. Does anyone not understand where these numbers came from? Now, could we simplify that answer? Well, can you divide 48 by 6? Does it work neatly, or can you make it to at least a lower fraction? What do we get if we do that? Okay, so 48 divided by 6, 8. I'm going to kind of show that way. Is that comfortable for everyone? I kind of cross them off and say, when we divide 48 by 6, we're left with 8 up top. And then what about x to the exponent 5 divided by x to the exponent 2? Well, every x on the bottom of this fraction can cancel out one on top. Does that make sense? The other one's just x divided by x. So if we use the 2 on the bottom to cancel out ones on the top, how many are we left with? Very good. So we'd be left with x to the exponent 3. And in this case, it's not even a fraction that we're left with. Well, that's strange behavior. So again, you understand the journey from here to there? We have 2 fractions. So we multiply the numerator times the numerator. That gives us our new numerator. 4 times 12 is 48. X squared times x cubed is x to the 5th. Then on the denominator, in times 2 is 6. X times x is x squared. That's comfortable for everybody? Then from there, this can be simplified because 48 can be divided by 6. That gives you 8. And if we have 5 x's on the top of the fraction and 2 of them on the bottom, 2 from the bottom cancel with 2 from the top, and that leaves us with x cubed. All right, I'd like you to try the example down below. This one has A's and deal with the letters one at a time. So let's press the arrow. My grandfather called. I've never quite been able to communicate to him that I teach for a living, and thus during the day I'm not available to talk on the phone. It's better than when he discovered Skype. For a year of my teaching career, I would intermittently be teaching. I eventually just had to uninstall Skype because no matter how much I tried to explain to him that at 1 in the afternoon I talked. So Skype. And yeah, the only thing you could do, in this case, when you cancel the A's, the one on the top. Yes, you can have negative exponents, but for the purpose of this unit, we're going to stick with staying on the bottom for their own part. It wasn't wrong. It's just not how we're going to do it. Does that make sense? Cool. That's it. Oh. Got it. Oh, you didn't undo this. Because we know that you that.
Yeah, I just.
Oh, you're doing great. So, what do I want to do? Let's keep this one apart. How many A's do you have on the top? How many do you have on the bottom? So these, like, I think of as like a war. They go to battle and like slaughter. Who's going to have A's left over? The numerator or the denominator? Great. How many? Good. So put that down. Maybe just put A. Oh, did you end up on the top? How many A's do you have? It's okay. Does that make sense though?
Yes.
Great. And then what about B's? How many up top? And how many on the bottom? So if they go to war, how many are on the top and bottom? You got it. Perfect. Good job.
Oh, thanks.
You're welcome. That's great. Were you following along as I was ranking, or did you already have that? Oh, that's okay. But does it make sense to you?
Yeah.
That's great. Good job.
My body tastes like so. Do you want to go
So
get
you
something
were
else?
90% right.
Don't do it, Dana.
So-
I swear to God.
The 40 you got five.
No, I don't think it would go with that.
Now, it looks it may or may not have happened. It also matters. You had A up top, and you had A squared down. That makes sense? So if you don't think about it, the denominator is
Maybe my niece is okay.
if they don't
But
go
it's
squash,
still real. I'm gonna
just
tell
say take one of those A's. How many left?
Mama.
Is it on the top or is it on the bottom? Who have
And
left?
I'm gonna tell him it has
Does that make sense? Is it a more so? And then you got this one back.
I'm gonna tell him too.
Four. You always going to be left with another where it started at. Does that make sense? Did you have the same time? And does that make sense to you?
But sometimes I feel like
That's exactly right. Okay, so can we go through this example together? Can I ask you what your next line was?
yes.
Yep.
40.
Yep.
A, B, power 5
Very good.
over
Yep.
A squared B.
Very good. Great. How we got that. Again, we're just multiplying numerator times numerator. 10 times 4 is 40. A times no more A's, because we still only have one A. It's on the exponent. And then B squared times B cubed means that altogether there's 5 B's being multiplied together on the top. So B is the fifth. Good. On the bottom, 4 times 2 is 8. A times A is A squared. There's no B's here, but we get 1 here. So there's a single B. I'm pretty confident everyone had that, so it seems like we're comfortable with that. Dividing, you guys did great. I was worried I'd have to coach you a bit more there. Divided by 8 leaves us with what? Yep, 5. Great. And now, I said this to a bunch of you individually, but think of it like a battle. Think of it like the A's and the A's go head-to-head from the numerator and the denominator. So you can always tell where you're going to have some remaining. How many were on the top in this case? For the A's. Yeah, what's the exponent on it?
Well, right now there's like invisible.
Yeah, that's right. So we only had one A on the top. How many on the bottom? 2. So who's going to have leftovers when this battle's done? Bottom. How many will be left over? Yeah. And so we're left with just a single A on the bottom. That's true. And then what about the B's? We have one B on the bottom. How many on top? 5. So if they go to battle and one annihilates the other, how many are we left with? 4. And are they on the top or the bottom? Very good. And I find it very helpful to kind of cross off like that as I go through. You may find the same, you may not, but to me it helps me kind of organize my thinking. So I would have 5 left on the top. Do I have any A's left on the top? But I do have, I have a single A on the bottom. Very good. Do you guys want me to do one more off to the side to give you a bit more practice, or do you feel comfortable with that? Would one more be helpful? No? No, it doesn't seem to like you people are okay. So now, to this today, we're going to work with polynomials. When we see something like this, what do you notice up top here? Addition. Okay. We want it to be straight multiplication and division. So anytime we come to something like this, we're always going to factor. It's the only new trick with this. We're always going to factor everything we possibly can. That makes sense? And that's why I said when we get to this unit, we're going to do a lot of factoring. We'll do a lot of factoring when we get to this unit. That's not so bad. I promise. So you just work one section at a time. How many fractions here? And each of them has a numerator, each of them has a denominator, right? So we just go one at a time. We go to the first fraction, we look at the numerator. Is there something I can factor out of this easily? Like, do I have to use the sum and product rule for this? Or any nonsense like that? What can I factor? What do they have in common? Yeah, what do they have? A. Yeah, they both have an A. So I can factor out an A. A plus 2. That looks like a 9, doesn't it? That isn't better. If he argued, it's a lot worse. How's that? That's the best I can do. I hope it's good. What about the bottom? 3A. Can we factor that? No, right? It's already as simple as it's going to get. So we can just write that as it is. What about on the right side? Can I factor 20A squared? If there's no addition or subtraction, there's nothing to factor. It's already just multiplication. So if there's no addition or subtraction, you never need to factor. Maybe even make a little note of that for yourself. Who's trying to kill you?
and the gum was purple and it tasted like soap, and now I feel like I'm gonna vomit.
I'm sorry. I thought I was going to have to like, beat somebody up for you. I'm tough like that. I totally will. So 20a squared doesn't need to be factored because there's no addition or subtraction. It's already factored. What about the bottom? It does have addition, so we're going to need to factor it. But this is still a nice, easy one. How can I factor this? What do they have in common?
5.
Yeah, I can factor a 5 out, and what does that leave in the bracket for me? Am I going too quick?
We have plus 10. It's just my page didn't have.
Really?
Yeah.
So mine was missing an X on the previous page, and yours is missing an A here. I printed these all from the same document. There should be an A down there. Can you all write it in? It really did. Can I see? Does it have something?
No, it was.
It's really weird. Okay, so put an A in there. That's... Okay, so the same thing yesterday. Every time I print something on these school computers, it behaves super bizarrely.
And that's really bad.
Yeah, no, it is. This is the same document. That's really weird. That is very strange. Okay, anyway, so we factored the 5a. I'm sorry. What remains in the bracket? Very good. A plus 2. Now again, now there's no addition or subtraction. And I know that there's addition inside the brackets. That's okay. We're now going to treat that just as a single term. Once you factor, you're never going to expand. Does that make sense? We're never going to FOIL this back out or expand it back out, use the distributive property. Once it's factored, we're going to cancel. Does that make sense? So when we multiply, we really are just doing numerator times numerator, denominator times denominator, right? The nice thing is when it's in factored form like this, it means you can just write it fraction. Does that make sense? So the a plus 2 will still be up there. I usually put the number first, so I'm going to put the 20 in front. Squared, how many a's do we have here? For a total of how many?
3.
3. Does that make sense? Everyone comfortable with that? Oh, gosh, that's pretty. That appears to be, oh, I know exactly who that is. It is Vincent. Used to steal my computer and sketch creepy looking things from. Yeah. So 20a cubed a plus 2. Everyone comfortable with that? A times a gives us a times a squared gives us a cubed. 20 is the only number, and we leave that a plus 2 in the bracket. You don't expand it. Once it's factored, you're happy to keep it factored. What's going to be left on the bottom? 3 times 5 is 15. A times a is? Yep, a squared. And then the a plus 2, do not expand it. Just leave it where it is. Does that make sense? Then yes. Now this is just like what we did yesterday. We're going to cancel. And I'm going to get in the habit of stating restrictions as well. Remember yesterday we talked about restrictions? Values of x that aren't allowed? A. From this bracket, what can't a equal?
-2.
Yeah, so a can't equal -2. And this a that's all by itself.
Just 0.
Just 0. Whenever you have an a not in a bracket, a can't equal 0. Very good. Usually I have to really beat that one out of people. That's great. So state your restrictions before you cancel. And then you can cancel. Is there anything on the top that's also on the bottom? Simplify. What do you think? What do you think? What's on the top that's also on the bottom? Yeah. How many a's are on the top? How many a's are on the bottom? If they go to war, how many will be left, and will they be left on the top or on the bottom? We're going to assume they have equally good strategy, which is to say they're multiplying and dividing. So who's left over and where are they left over? Yeah, how many of them?
Just one.
Just one. 2 of them are canceled on the bottom. 2 of them are canceled on top. Leaves us with just one. As long as it doesn't. Anything else I can cancel from top to bottom? What do we got? Things that are the same on the top as they are on the bottom. I see a big one. Is anyone else? God, I'm gonna make you guys go like run some laps with me around the field. It's not gonna be too long. I would probably die of a heart attack if you put a wrinkle in the whole thing. Yeah, what do you see? Yeah, that's right. We have an A plus 2 on the top. We have an A plus 2 on the bottom. It can go. Okay, so A plus 2 on the top, A plus 2 on the bottom. And then what about 20 and 15? Can we simplify that? Yeah, we could divide them both by 5, right? So we could leave 4 there by dividing by 5. Good job. Good. That's the least important part. Like if you left over as 20 over 15, I'd give you all the marks. So now, maybe forever, I don't know. So what's left? I know it's kind of tough to see with everything we've canceled here, but what's left on top?
4a over 3.
Yeah, we've got 4a in the numerator, and that's what we have as well. This is, I like all math. This, I think, is my favorite kind of math, because you start with these big, ugly expressions, nice, just with a nice, really simple, little elegant answer. There's just something about that I find. Worse or more exciting? I think it's exciting. Anyway. I agree with you about Michael Bay, but I'm not sure I agree with you in math. Okay, here we're going to get some factoring practice. Ready? Yeah, you totally are. You're totally ready. Don't let it stress you out. Like we said before, how many things are there? There's 2 fractions. Each of them has a numerator. Each of them has a denominator. So how many things are we dealing with total? Just 4. We're just going to go one at a time. Okay, one at a time. Which one do we do first?
The top one.
I'm actually going to do this one first. Why? Can I do anything with x minus 4? Anything I can factor? Anything I can do? No. So here's what I do. To remind myself that it's as factors as it's going to get, I just put in a bracket like that. Factors, right? So I put in a little bracket like that, tell me that one's done with, it's dealt with, I can't do anything more. Does that make sense? Is there another one that jumps out at you as relatively simple? Yep. Yeah, this one looks pretty simple, doesn't it? What can we do with this one? What do they have in common? They both have an x. So that's an easy factor. I put x in front, and what remains inside? Very good. So that's a nice, easy one, too. Now the other 2 are trickier. Which one do you want to do first? That's not one of the options.
The top one? Yeah.
We'll do the top one first. Okay. So for this top one here, numbers that multiply to what? 2. What are the possibilities?
1 and 2.
1 and 2?
Negative 1.
-1 and -2. That's it. Those are the 2 options. What do they have to add to? 3. So which pair works?
1 and 2.
1 and 2. That wasn't bad, was it? Now here's what we're going to do, though. We're not going to do decomposition. It takes 6 steps to show this, because we know the answer is going to be, and what's going to be in both of those brackets? Only the number yet, but just x. We know there's no number in front of those x's in front here. Does that make sense? So we know that this is a simple sum and product. So then how do we find the numbers that go in there? We just found them, right? 2 numbers that multiply to 2 and add to 3. What numbers work? 1 and 2. So we put plus 1 here. Again, I'm not trying to criticize, and listen, if the decomposition steps are necessary for you, that's fine. Don't do them on the page here. Go to the side of the page and do them. Does that make sense? You don't want to muddy this up. This is plenty muddy already, isn't it? Let's not make it worse. Can I leave this one with you and walk around? The second one? We know what the answer is going to look like. Is there a number in front of this x here? No number in front of the x's in these brackets. So it's going to be and x and a number. I'll come around and see if I can find it. Of course. Yeah. Good job, by the way. You were so close. You're so close. My problem is this. If I multiply those, I get positive. And I get -5. So one of them has to be positive. Well, that's good. You count the numbers. You just gotta watch those signs, right? Let's see. Hold on. You can do that. It does work. It's not easy, but it does work. And if you want to do it every time, it will not fail you. But it's a lot of work, and you have to know that factor at the end. And that's not as easy as one might think. You're right. Finding the numbers is not, that's some grade 12 stuff usually. So eventually, like next year, you're gonna have to do something. You work out like that. Trust me that it's not actually easy. And I trust you, by the way. So may I ask, what, please? Well, I'm still gonna ask, but now I feel guilty about it. What pairs of numbers could work to give us -4? 1 and -4, or -1 and 4, right? Anything else? Maybe 2 and -2. Does any of those pairs add to -3? Pairs adds to -3. The top one. Okay. So what do I do with those numbers? Great. So like this. Yeah, that looks great. That one's kind of ugly. Better. Sorry? Always seems to be mine. That doesn't. All right. Now again, because it's multiplication, and we don't want to expand these, we can just write them out all in order. X plus 1 plus 2. Those are our factors on the top. What are the factors on the bottom? We have x minus 3, x plus 1, and x minus 4. Now, at this point, before canceling, I want to state restrictions. Look at our denominator. What values of x will make this thing blow up, will make it not work? Well, we said a letter by itself always disallows what? If I have a letter all by itself, I can't let that letter be 0. So x can't equal 0. What about this bracket? X can't equal this bracket. Very good. What about this bracket? Good. See, that's not bad, is it? Sorry? Did I screw up? Can the top be 0? No, it's okay. Oh, I'm sorry. I didn't mean to be negative. But it's okay for the top to be 0. That's allowed. That just means you have $0 and you divide that amongst all your friends. Everyone gets nothing. That's allowed. It sucks. It's not a very exciting Christmas, but it's allowed. Sorry? Is that every Christmas? Oh, I'm sorry to hear that. My wife and I, the year we were married, we set ourselves a $20 limit for Christmas buying, and every year we reduce it by $1. So this past Christmas, we had $9 to spend on one another. So I went thrift store shopping and got some very nice stuff. But it's an interesting challenge. Can you get a good gift cheaply? Right? Like anyone can spend a fortune and get a good gift. But gift? Can you spend very little money and get a good gift? The answer largely is no. They're usually pretty crappy.
Do you still get me a nice gift?
No, it's in the rule book.
What?
Listen. The trick to gift giving isn't doing well at Christmas. It's doing well on like a random Tuesday in February, where you go, no, not that one. That's the worst time. And you go, I saw this thing and it made me think of you. I meant like today, like if I was like, just driving home and I was like,
I guess, but like when everybody gets like bomb gifts on Christmas and then she gets like a $2 gift.
$9. And that's what she has to spend on me. She got me 2
Wait,
books.
do you have to spend 9 or can it be less?
It can be less. That would be insulting. Like I spent 3 and pocketed the 6 for myself. I'd be hurt. But actually, I'm the worst gift recipient because I don't have expensive tastes. I'm pretty boring. But I'm also selfish. So if I want something, I just buy it for myself. So when Christmas comes, there's never anything to buy for me. If I want it, I've bought it. So I don't envy someone who has to buy me a gift. Anyway, how do we cancel here? What cancels? This one?
Yes.
Yeah, I like that. What else? Is there anything else? Yeah, x plus 1 cancels. Is there anything else? No, they have to be identical. So if they're not identical, they don't cancel. And so what are we left with? On the numerator? Very good. And in the denominator, what remains? Yep. Like that, right? How did you? And we know our restrictions come from before canceling. So x equals 0 is impossible, x equals 3 is impossible, x equals -1 is impossible, and x equals 4 is impossible. So bad, is it? Admit it. Just ready? I'm ready. It was a little fun, right? A little bit. No, listen. You're screwing your face up because you feel like you have to. It's like clapping. It's like singing along with the opening act, right? You don't do that, right? But you kind of want to. It's like they're pretty good, and like stuff's catchy, and you guys like dancing up the intro. That was kind of fun.
Yeah.
You start with all that nonsense, and you end up with this elegant, beautiful answer.
Elegant. Elegant.
Constants are my thing. When I was at Brock, I discovered I was poor. I had no money, like most college students. But I convinced the school newspaper to have me write concert reviews. They would send me the concerts. And I, as it turns out, I'm not a good writer. But that's okay, because I got to go to a lot of concerts, and it was great fun. I also briefly wrote the political column, both the right-wing and left-wing column, both under fake names. And it was great, because for a while I wrote, this is kind of crass, sorry, like this, if you're listening, like Alondra's mom or whatever. But I once wrote an article, so again, I wrote both. I wrote like the conservative one and the liberal one. But for a while, I wrote the conservative one under my real name about why they should raise tuition, but give more money in scholarships. So my argument was that's what California does. If you want to go to the University of California system, it costs like 55 grand a year, 60 grand a year. But nobody whose family makes less than 80 grand a year pays a dime. And then between like 80 grand a year in family earnings and 150 grand a year in earnings, they start to scale it up. So that people who the cost of that would really be prohibitive, they get a free ride as long as they get in. But then for people who have the means, it's expensive. And my argument was that was a better idea. But I titled this article, Raise Tuition Now, with a big exclamation mark. And I was walking down the hall at Brock one day, and I heard, and this made me proud to this day, I heard these two people sitting, they had the newspaper, and they went, Joe Orlando, what an asshole. They're not wrong. Anyway, does anyone remember from grade 9 math how we divide fractions?
Nope.
How do we divide fractions? I just did this with my grade 9s. I taught them to divide fractions. I still haven't taught them to divide in the halls and walk single file, but we'll get there. But anyone remember? Right. This is what I'm saying. It's kind of a weird trick, and if you really want me to go back and teach you why it works, I can. But do you remember you switch the division sign to multiplication and you flip the second fraction? Does that ring a bell? Invert and multiply? You probably heard that 2,000 times in grade 8 and grade 9. But what we do is this. We rewrite the first fraction. And then the second fraction, we invert it. The bottom becomes top, top becomes the bottom. So what will I write for the second fraction here? 12b squared, 15a squared, multiplication question. That's it. Any division question, the first thing you do, just make it a multiplication question, and then go. That's the whole trick. You invert and you multiply. And then, times 12, 120. How many a's are there total on top? How many b's total on top? Yeah, good. Times 15. Good. How many a's total on the bottom? Good. How many b's total on the bottom? Perfect. There we go. That comfortable for everybody? Now, can we simplify this? Cancel things? Yeah. So what's that leave us with on the top? Yeah. And then what about the a's? The 1a on the top goes to battle with the 3 a's on the bottom. What are we left with?
We're left with 2 a's on the bottom.
Yeah, nothing on top and 2 a's on the bottom. And then are there any b's to do battle in the denominator? No, so we just leave that alone, right? And our answer would be 2 times b to the exponent 4. By the way, again, if you want to lie to me and say that doesn't feel a little ugly and making it so elegant at the end, that's fine. You can lie. I'm just saying it's like one of those 80s movies where they take like the awkward teen who obviously isn't an awkward teen at all, but they've just taken somebody really attractive and put glasses on them and like given them somewhat disheveled hair. So you're like, oh, that's the awkward looking person. And then at the end,
Work with me, okay?
and at the end there's the big reveal where they come in and like all they've done is like somebody combed their hair and all of a sudden they're like, oh, she's beautiful. Anyway, that's what this is like. You've got the awkwardness at the beginning and then you get this elegant, beautiful ending. It's basically a teen comedy. All right, you try the next one yourself. It's because it doesn't have to, right? Be positive. You're really bad at the encouraging friend role, eh? That's not your wheelhouse.
No.
All right, that's good to know. This step is always so that you will multiply. You actually start doing this fraction go along. That one unit second one. Oh, I get it. It's a long. Oh, I'm sorry. Yeah, that's what I got. That's what I got.
Cool.
You know why? Yeah. better than Okay, when we have a division question, what are we going to do first every time? Switcheroo. Yeah. So what would I write here? This first one stays the same. 6xy squared over 7xy cubed. Yep. Very good. Now we can actually do this multiplication. What do we get when we do that? Yes, ma'am.
30 x y 4.
Yeah.
Over
X times y to the fourth power over
8 y cubed.
Perfect. Okay. Now let's get to it. Madam, is there anything we can do with 30 and 28? Yep. And what do we get? What are they both divisible by? 2. What's that leave us with on the top? And on the bottom? All right. And then let's talk about the x's and the y's. When the x's go to battle, how many in the numerator? Isn't there one? I think there's, oh, like when we're done.
Yeah.
Yeah, when we're done, the one on the top cancels, and how many are we left with on the bottom? Good. It's super finicky today. I don't like it. And when the y's go to battle, how many are left in the bottom? We start off with 3. How many in the top? So where will there be a leftover?
With the y on top.
Yeah. The ones on the bottom are all gone, and we're left with just the one on top. Leave me with as an answer. Yeah.
15y over 14x squared.
Very good. Well done. Does that make sense? I am going to pause there for the day because I don't want to just do example after example and make you miserable. And that's actually, this is a very nice tomorrow. Excuse me. Well, that's another weird one I noticed, is that this put a random symbol in there and I had drawn division. And again, same file. Very strange. This is correct, right? Yours says division. Very strange. Anyway, your homework is this. Even if you have to get to these bottom ones, you know what to do. You just factor. But work your way through it. I'm happy to help you right now. Tomorrow, we'll finish this sheet. We'll also do some factoring problems tomorrow. And then tomorrow, we probably won't go on to another topic beyond this. We'll probably finish this example and then just do some practice together. Let's make sure we're all on the same page. Does that make sense? I want to go slowly through this topic because it is tricky. Lots of practice, lots of time to make sure we get it perfect, but make sure you do your homework.